Hello students, welcome to a series of mathematics program for grade 10. The topic for today is variation. This topic has been divided into two parts, and the first part is direct variation, which we are going to consider today. So as I have mentioned, variation is divided into two parts. We have direct variation and indirect variation, or most commonly known as inverse variation. So at the end of today's lesson, you should be able to understand the graphical representation of a direct proportion, and you should also be able to express direct variation in algebraic terms, as well as use this form of expression to find unknown quantities. So let us start with this table. You can observe that in the first row, we have number of cards, and in the second row, we have the cost in rupees. So for example, if 2 cards are bought, the cost will be 100 rupees. If 4 cards are bought, the cost will be 200 rupees. Similarly, if I decide to buy 10 cards, I will pay 500 rupees. So this information has been illustrated on the graph here. On the x-axis, you have number of cards, and on the y-axis, you have the cost in rupees. You can see that we have a straight line. Now, based on the table showed previously and on the graph, what can you observe? You can see that as the number of cards increases, the cost also increases. We say that the cost is directly proportional to the number of cards. So if, for example, y represents the cost and x represents the number of cards, we can say that y is directly proportional to x, or we can also say that y varies directly as x. This means that as x will increase, y will also increase. Or if x will decrease, y will also decrease. So this is written as y with this symbol, y varies as x. So this symbol means varies as. It is called the symbol of variation. Now, we consider the table again. You can see that y is the cost and x is the number of cards. So y over x will be 100 over 2, which is 50, or 200 over 4, which is 50, or 500 over 10, which is 50. In fact, for all the different values of x and their corresponding values of y over x will give me 50. In other words, we say that the corresponding value of y over the value of x is equal to a constant. And here the constant is 50. So we can also write it as y over x equal to k, or y equal to kx. Hence, if y varies directly as x, this will imply that y equal to kx, where k is a constant. Sometimes we also call k as the constant of variation. So I repeat, this is very important. If y varies directly as x, then we will have y equal to kx, where k is a constant. So let us consider the first example. We have two tables and we need to determine whether y varies directly as x. And if y varies directly as x, we need to find an equation connecting y and x. So we consider the first case. Part A, we have this table. Let us find the value of y over x for each of these columns. So y over x here will be 21 over 3, which is 7. For the next column, we will have 35 over 5, which is 7. Here, 49 over 7, which is 7. And finally, 70 over 10, which is 7. So we can see that y over x is equal to 7 for the different columns. We can therefore say that y varies directly as x. And the equation connecting y and x will be y equal to 7x. Now we look at the second table. So here, y over x will be, for the first case, minus 4 over 2, which is negative 2. The next column we have 12 over 6, which is 2. The last column, 24 over 8, which is 3. So you can see here that we do not get the same value for y over x. As y over x is not constant, as I have mentioned, we get negative 2, we get 2 and 3. We do not get the same value. So since y over x is not constant, we say that y does not vary directly as x. So for y to vary directly as x, we should get the same constant each time for y over x. Second example, if y varies directly as x and y equal to 12 when x equal to 3, find part A, an equation connecting y and x. Part B, the value of y when x equal to 6. And part C, the value of x when y equal to 20. So here we have been given y varies directly as x. So if y varies directly as x, we can write it as y equal to kx, where k is the constant. So we were also given that when x equal to 3, y equal to 12. So we replace these values to find the constant k. So we get 12 equal to k times 3. That is 3k equal to 12. And k will be equal to 12 divided by 3, which is 4. So I can rewrite the equation connecting y and x as y equal to 4x, because now I know the value of k, which is equal to 4. So initially I had written it as y equal to kx, and k now is equal to 4. So the equation will be y equal to 4x. This is also sometimes called the equation of variation. Part B now. I need to find the value of y when x equal to 6. So we were given this equation, y equal to 4x from part A. We found it. Now we replace x equal to 6. So y will be equal to 4 times 6, which is 24. Next part, I need to find the value of x when y equal to 20. So again, we will use the equation which we found in part A, y equal to 4x. And we replace y by 20. We have 20 equal to 4x. So x will be equal to 20 over 4, which is 5. Now look at example 3. Given that v varies directly as t, copy and complete the table below. So this was the table given to you. And you were also told that v varies directly as t. So how can you write it? Yes, v equal to kt, where k is the constant. Now, we have 3 different columns, but you can see here that we have a value of t as well as the value of v. So I'm going to use these 2 values. When t equal to 6, v equal to 30. So I get 30 equal to k times 6. That is 6k equal to 30. And k will be equal to 30 over 6, which is 5. So the equation connecting v and t is v equal to 5t. Now, when t equal to 3, I'm going to replace, so I get v equal to 5 times 3. Remember, the equation is v equal to 5t. So v equal to 5 times 3, which is 15. Next, when v equal to 60, I will get 60 equal to 5t, and t will be equal to 60 over 5, which is 12. Now, there exist other forms of variation. So let us look at one such form. Example 4 now. Given that y varies directly as the square of x. So now we have the square of x, and y equal to 16 when x equal to 2. Calculate the value of y when x equal to 8. So here, y varies directly as x squared. So I will get y equal to kx squared, where k is the constant. You have been given that x equal to 2 and y equal to 16. So we replace these values. We get 16 equal to k into 2 to the power of 2. So 4k equal to 16, and k will be equal to 4. So the equation connecting x and y will be y equal to 4x squared. Now, when x equal to 8, I need to replace. So I get y equal to 4 times 8 to the square, which is 256. We now move on to example 5. Given s varies directly as the square root of t, and s equal to 6 when t equal to 81, Calculate the value of part A, S when t equal to 144, and B, t when s equal to 20. Now, very often in questions, you are not asked to find the equation. But even if you're not asked to find the equation connecting the two variables, you have to find the equation. Because with the equation only that I can find the unknown values. So here s varies directly as the square root of t. So I will get s equal to k square root of t, where k is a constant. Now, given s equal to 6 when t equal to 81, so I will replace these values to find k. I get 6 equal to k times square root of 81, which is 9k equal to 6. Remember, square root of 81 is 9. So I get 9k equal to 6. K will be equal to 6 over 9. Reduced to lowest terms, I will get 2/3. So k is 2/3. Now the equation connecting s and t is s equal to 2/3 square root of t. Now, part A, I had to find the value of s when t equal to 144. So here's the equation, s equal to 2/3 square root t. I replace t by 144 and I get s equal to 2/3 times 12, which is 8. The second part now, I need to find t when s equal to 20. So again, I use the equation s equal to 2/3 square root t. I get 20 equal to 2/3 square root of t. So square root of t will be 20 times the reciprocal, that is 3 over 2, which gives me 30. Now to find t, I need to square on both sides. So t equal to 30 to the square, which is 900. So students, you now have some exercises for you to practice on what I have just explained to you. So you have different forms of variation. For example, the first one is y varies directly as x. The second one is y varies directly as x squared. The third one, you have y varies as the square root of x. Question 4 is slightly different. You have t varies directly as v minus 2 to the square. And question 5, you have r is directly proportional to p cubed. Question 6, you have L varies directly as the square root of A. Question 7, you're given that V is directly proportional to square root H and V equal to 70 when H equal to 100. And you need to find the value of H when V equal to 35. Question 8, you have to copy and complete the table given that y varies directly as x. And question 9 is slightly different because C rupees of transporting materials varies directly as the distance d kilometers. Given that C equal to 1000 when d equal to 10, find part A, C when d equal to 18, and part B, D when C equal to 1500. You also have some interesting links for you to go and practice more questions as well as watch some additional videos on direct variation. So students, we have reached the end of today's program and let us quickly see what we have learned. So today we have learned how to represent the graph of direct proportion or direct variation of two given variables. We have also learned how to express direct variation in algebraic terms and how to use these to then find unknown quantities. So students, I hope you have understood the first part of this chapter, that is, you have understood the concept of direct variation. And until we meet again in the second part of this chapter, it's goodbye from me.